cannot slow the vertical descent of a body falling through the atmosphere or the velocity of a body moving horizontally. The parachute increases the body's surface area, and this increased air resistance slows the body in motion. There are two forces acting on a parachute with the parachutis: the force gravity and the air resistance. As the skydiver falls, he encounters the force of air resistance. The amount of air resistance is dependent upon the two variables: the speed of the skydiver and the cross-sectional area of the skydiver. As the skydiver falls, he accelerates downwards, gaining speed with each second. The increase in speed is accompanied by an increase in an air resistance. This force of air resistance counters the force of gravity. As the skydiver falls faster and faster, the amount of air resistance increases more and more until it approaches the magnitude of the force of gravity. Once the force of air resistance is a large of the force of gravity, a balance of forces is attained and the skydiver is no longer accelerates. The skydiver is said to have reached a terminal velocity. The importance of cross-sectional area to skydiving is also demonstrated by the use of parachute. An open parachute increases the cross-sectional area of the falling skydiver and thus increases the amount of resistance which he encountered. Once the parachute is open, the air resistance overwhelms the downward force of gravity. The net force and the acceleration of the failing skydiver is upward. An upward net force on a downward failing object would cause that object to slow down. The skydiver does slow down. As the speed decreases, the amount of air resistance also decreases, until once more the skydiver reaches a terminal velocity.